In this example, we're going to be looking at the interaction between the Gini index and violent crime rates in different neighborhoods within Chicago. In order to do this, we need to go ahead and understand what our correlation coefficient is, and R in this case is 0.676. This tells us a couple things right off the bat. First of all, it's positive, and what this means is that as the Gini index for a neighborhood increases, as inequality increases, we see violent crime increase as well. So first of all, it's positive. Increase in one is an increase in the other. The other thing to notice is that this isn't a small correlation coefficient. A 0.676 means, well, it's not exactly linear. We do have a linear trend. So this data, as we go over, that is, as the Gini index increases, we're seeing a semi-linear relationship in that violent crime is increasing as well. Now, a quick word about our variables. As a reminder, the Gini index is always going to run from 0 to 1, and violent crime rates here are actually weighed, so this will be the number per 1,000 people in that neighborhood. Once we have that our correlation coefficient is 0.676, we need some other information to create our regression equation. We need to go ahead and figure out what our averages are and what our standard deviations are for each of these variables. We'll start by listing the numbers we have for our Gini index. We're listing this first because this is going to be our independent variable. That is what we plug in. In essence, this will be our X values. Then we'll go ahead and list our information for our violent crime rates. This will be our Y because it's what we're going to be predicting. It's worth noting as we look at these numbers that the variation for our violent crime rates is ridiculously high. That is, while there's an average of 20.5 violent crimes per 1,000 people per neighborhood, we're seeing that the standard deviation of 18 is almost equal to our average, which tells us once again, neighborhoods are very different from each other when we're in Chicago.